probably have used GoCD at some stage in your early careers, or Selenium. Those are things that have started their lives in ThoughtWorks. And just last week, ThoughtWorks was recognized for its work with BAMNI, the hospital management system that we've built mainly for South Asia, where we're effectively providing open source, free support to hospitals and clinics in South Asia. And on that theme of open source, we've all used open source, and I like Philip's point, so at some stage you have to give something back. And because we have lots of customers in the automotive world, we obviously build backends as well. I can't see the slides here, by the way, so I don't know how to press or do whatever. Just press and it'll work. Okay, cool, thank you. We have a CSMS that or parts of a CSMS that we've developed, and we're going to talk to you about today. That's We already had that. So MaEVe, real quickly, has two versions, an open source and sort of a private code base. The open source version really is targeted at technical practitioners, so we say it's the CSMS for developers. We've built it so that it's easy to engage with. Hopefully you'll see that as well in the coming days. It's very flexible and really lovely to observe what is really going on, something that we typically in the commercial systems don't see. As developers, obviously a nice thing to have. And we've set out with MaEVe to solve some of the hard problems. And Dale and I had the conversation of, we had some time on our hands when a customer went into some internal conversations and didn't have use of our time for the moment, and we were parked for a little bit. And so we said, well, why don't we just show them how our software engineering practices apply to them and how we would solve problems differently. We all know how corporates develop software, and there's another way. And so we set out to do that, and Dale asked me, well, what would be a hard thing to do for people these days? I said, well, why don't we start with OCPP2 and plug and charge? That seems like a reasonably chunky thing to solve for, and we had about 3 weeks' time. Naive as Dale was back in the day, he said, yeah, okay, fine, I'll give it a crack, and had a team with him, and we started chipping away at that, and that's effectively the nucleus of what we've open sourced as well. We have a private code base as well that we use with our customers who want to develop their own CSMS or are looking for bolt-on solutions to existing services, or just need a broker to attach to an existing system for something as well. And obviously all the business logic is then our consulting services that we offer to implement with. By the way, Philip's point about consultancies are evil, yeah, I agree. What we like to do, though, is help our customers become independent. We always tell them, hire your own developers, learn, grow, stand on your own 2 feet, own the product, don't rely on externals for everything. We'll help you get there. And then we move on and do something else again after a while. So what is MaEVe and how is it different? Well, firstly, it's open source and it's current. I guess that's sort of the thing that nagged at us when we started this early last year. There wasn't really anything in the market that was current. We all use Steve and many other open source projects, but we needed OCPP2. So that's what we did. We implemented OCPP 201 with plug and charge. Quickly realized there was nobody to talk to anymore, so we ported plug and charge backwards to 1.6 as well, so we could play. And Dale will go into a bit more of how that journey went and who all was part of the journey, which is actually very nice to see many of the faces again here. We've got the basics of OCPP 1.6 implemented, and I say basics, At first we said, well, let's just put the core profile in. But actually, we realized the way people use it, we don't actually have to do all that work, because either people want it and they can do it themselves because they're capable and off they go, or they don't need the full profile anyway for their use case. So we stopped and sort of devoted ourselves to other things. And whenever we have projects or explorations into a few new projects, we add little functionality. So like there has to be extensions at some stage were needed for some test routines, so we added that in. It's written in Go, which we thought was a really useful choice at the time. Still think so, actually. And we have an architecture where the microservices talk to each other in MQTT, which makes it really easy to plug into other things that are happening in your ecosystem as well. We have infrastructure deployed as code, particularly the load-balanced mutual TLS has taken a bit of thinking on how to get that deployed on Google and to get it all automated and up and running. It was actually surprising that I think took us longer than some of the OCPP implementation to get all of that set up. And we've got, this is typical for ThoughtWorks, because we usually work in test-driven development setup, so you'll find a very high test coverage. So if you want to go and play with it, there's plenty of tests already there. You can have a crack and you can see what you can break and what you can add. And you all know about all the acronyms with O's and P's in them that we all need to make our ecosystem work. A lot of that has been implemented as well. And then, of course, at some stage, we started playing around with having MSP services plugged in as well. So we had a basic OCPI implementation attached into MaEVe as well. So some of the elements of what you will find when you open the GitHub, it's a Apache 2 license, so pretty much knock yourself out. Maybe permissive, too permissive, let's have that conversation. I'm happy to learn more on that, but it was our idea of saying, you can take this and you can build your product with it, or you can learn with it, or you can just add bits of it. All of that is fine by us. Dale, I'll press the buttons for you.
Okay, great. Thanks. So, as Ian said, MaEVe essentially started life as a pitch to a client to tell them that they should really consider moving to OCPP 2.01, because there was lots of good things there, and to demonstrate that we could help them with that. And so we decided to focus on plug and charge. Now we had 3 weeks to demonstrate before we came to the pitch with them. So it's like, how do you go from nothing to a solution that you can demonstrate in 3 weeks? So we ran 3 one-week iterations. In the first week, we concentrated on establishing basic connectivity. So we had the CSMS, so we started creating the shell for that. And we had to, at the same time, create a combined charge station and EV simulator so that we could actually show the end-to-end process. So week 1, we handled like basic protocol messages. Week 2, we could then move on and actually start to look at the things we were interested in terms of plug and charge. And then in the 3rd week, we kind of polishing that solution. So we had a basic plug and charge solution after week 2, which let us, in week 3, look at adding support for receiving certificate hashes and stuff instead of full certificate chains, and making sure we did all the OCP checks, OCSP checks, and stuff like that. So in 3 weeks, we went from nothing to kind of an end-to-end solution. It was not complete by any means, but it showed the fundamentals of plug and charge. The way we approached this, we had a small team of developers, none of them had ever done anything with OCPP before. So our developers worked in pairs. This is a really useful technique we found because it allows for knowledge transfer. It allows for sharing experience, different modes of thinking. One person can be thinking about what they need to do right then, and the other one can be thinking about the longer-term impact of that and how it might fit into the rest of the solution. So pair programming found really useful. As Ian said as well, we used test-driven development, so that each feature that we were building, we'd start by building the tests that would show us that we'd actually got there and it worked. And then we iterate on the code until we got to a point where the tests passed, which gave us fairly good confidence that we'd built a solution that would actually work. So at the end of that 3-week period, we had a simulator for the EV, which had a demo UI on it so that you could visualize what was going on as we plug in, pause, resume, unplug, all the basic things that an EV will do with plug and charge. And then we had the CSMS at the other end, just doing the shell of a CSMS really, but it was doing the authorize scenario for plug and charge. It's great, but we're creating the client and we're creating the CSMS. We think they work together correctly, but it was like, what we want to do now is we want to go off and test that with somebody else's solution so that we can see if it actually works. Before I go that, I've forgotten a bit of my talk. So the EV charge station simulator, that was written with Python, and it used the Mobility House OCPP Python libraries. So that was, again, part of us gaining some confidence that the things that we were doing weren't entirely made up. And the CSMS, as Ian said, is written in Go, and we were using Hubject's Open Plug and Charge test environment to issue and validate the contract certificates. But now we wanted to go off and see, will this work with somebody else's solution? And we looked around and we came across Everest. And so it was like, okay, can we use Everest in its software in a loop mode to do some plug and charge with our solution? At the time we were looking, Everest's OCPP 201's implementation was incomplete. So this was the point where we said, okay, let's refactor and add support for OCPP 1.6 with the OCA plug and charge extensions. Something we didn't even know existed when we'd started this 3 weeks earlier. So, yep, 1.6, we did some refactoring, added the support for multi-protocol negotiation, and started working with Everest. We found some bugs in our implementation. We found the odd bug in Everest as well, and we were able to contribute PR to fix one of those. There may be some others, but I want to actually validate them with a much newer version of Everest than the one that I was working with at the time. At this point, we were able to run Everest and run MaEVe in parallel and test the two of those together and do a plug and charge over 1.6. At this point, it was like, okay, we've got something that's actually kind of useful. Because we'd looked around when we started this, and there wasn't really a lot of practical advice on how to implement plug and charge. You had to just discover all the different parts and how they were supposed to fit together. And so it's like, we've got a reference implementation now, And that sounds like something that would be useful to share with people. So that was the point where we decided to open source this, and we made the appropriate changes just to get it out onto GitHub. Yeah, we got this solution. It's like, we'd like to try it with some real hardware now, which meant that running it on my laptop wasn't going to work. So we did a cloud deployment of this. We popped it into Google Cloud. There were some interesting challenges, as Ian alluded to, particularly doing mutual TLS with a cloud load balancer. That's not a well-supported path, but it is possible. And so we did that. And then we went off and we worked with Ionity at their test site. We used an Eco-Energetica charge station, which was initially configured to use the has-to-be plug-and-charge extensions rather than the OCA ones. So we rapidly added support for those. We struggled a little bit with those, and we swapped to using the OCA ones. So that was some work there. We have also tested with an EcoG charge station and an ABB charge station. We also did some work to work with different plug-and-charge root certificate providers and certificate pool providers. And yeah, we've done some stuff with OCPI. So along with MaEVe, the charge station management system, we've also been doing some work looking at the EMSP part of the solution, a project that we've called MaEVe, which provides a mobile app that will let you, manage your contracts and stuff, and then's got subscription services and payments managed through Stripe. So to make all of this work, obviously, we need to be able to communicate between the CSMS and the EMSP, so we've started to add support for OCPI, and that's starting to fill out the behavior of the CSMS. Yeah, I think that's... So, we built MaEVe so that we could try and find solutions for some of the challenges that there are out there. And for each of those challenges, whether it was plug and charge, whether it was how do you scale a CSMS, or how are we going to integrate with EMSPs, we took the same approach. It's a case of identifying the thing we want to do, look to implement the thinnest slice possible so that we can start to get fast feedback, and learn from that feedback, refactor, and move on. And that's, yeah, I think that's it for me, and I'll go back to Ian.
Thank you. And I think that's pretty much how we work on all of our consulting projects as well, where we're probably almost never the domain experts, but have our way of inserting ourselves and applying our software engineering practices that help our clients. And so what have clients done? So we started our journey April last year and then open sourced it somewhere towards the tail end of summer. People have commented on, they really like the observability. So at the moment we've got Honeycomb or something plugged in, so you can exactly trace what is happening with my message, where is it going, where am I getting stuck, where have I got malformed data types or something happening. People enjoy having multiple protocol support in one tool, so that's not a given on some of the other open source versions. And we've done some synthetic load simulations as well to see where exactly the problems are going to come from as well. So that's all out there in the repository that you can access as well. And so we've had customers come back saying, well, actually, this is beautiful code. It's helped me understand what I'm supposed to be doing in my code base. There was others who just lifted some of our code and plugged it into there, and they were happy that things finally worked. We've had an oil and gas company's senior architect who said, I've been working on plug and charge for 5 months, and it still didn't work. Thanks to you, I've now got it in 2 hours. So they probably were just stuck in one last piece. But I really like the fact that they can look at the code base, understand it, and then work back to their own project. Obviously, we use it in CSMS implementations on behalf of our customers as well. And so usually starting from the private code base, which is a bit more elaborate than what is public. And people are using it, like I said before, for maybe we don't need the full-on commercial CSMS, not saying anything negative about the ones that are out there, but maybe customers don't actually need all of that stuff. They just want to be able to control a charging session. And they already have an ERP and a CRM system that does contracts and billings and all these other things. And they probably have a payment system somewhere too, particularly retailers or fleet managers. They have a lot of these capabilities. So what they need is an ability to talk to a charger and a clever way of integrating that back into existing systems. And so we're involved in a lot of projects along those lines as well. And that's a great starting point. And some people are using it to just teach their teams Go as well. As we see a lot of customers moving to Go, that's a well-documented code base. It's got a good starter for your test coverage. So have a crack, have a go. And that, I think, is everything we brought for you for today. I hope you brought lots of questions as well, because obviously there's a lot more to say, but we didn't want to bore you in the talk, so we'll make it specific. Go on, Robert.
I guess we will have questions. But first of all, really love to see the open source community effect. You guys just finding ever, starting to use it for testing. That's in the end where you build great communities. So, thanks.
Well, and I think anywhere from Steve to the Mobility House library to Everest to a few other things along the journey as well that have helped us. Yeah, sure.
I think almost anybody doing OCP knows Steve.
Yes,
Steve's been like central to everybody learning OCP.
Yeah, and
any questions?
We called it MaEVe as a nod to Steve, essentially. It was something that rhymed with Steve, although it turns out that my Irish pronunciation was wrong and it's actually MaEVe. But the intent was that it was there to rhyme with Steve.
Cool, didn't know that one. Any questions?
Maybe a bit of an obvious one. Have there been any performance comparisons between MaEVe and Citrine OS?
I haven't done any.
No. There's the basis there for doing those, in that there is some automated test suites that can be run as load tests. We've not tried to really ramp it up against our cloud setup. We've only ever actually run those tests on a laptop, which is running the load test and MaEVe and all the monitoring to go in with that as well. So yeah, I no idea how they would compare. It's fairly speedy though, but I'm sure Citrine is as well.
Across all the development you've shown, did you have a reference EV simulation which were in use?
A reference EV simulation.
I think we used the one that Cornelius supplied us with. We've done a lot of interoperability tests at the Hubject lab on the Ionity test side, and we just use real cars for that. And I think for the for efficiency of the developers, we had just wired up, I guess like everybody does, we've just sort of wired up the typical resistor base so that we have a basic AC charger that we could play with. and you can flick the switch on your desk and get some feedback. So we've done those kinds of things. I'm currently working on a better version of that as well. I guess like the Pionix team as well, as you develop, you realize just how much catch-up we have to do in the automotive industry in terms of efficient software development and getting faster feedback. And so building some of those automated system under test setups is on our mind. As you heard, test-driven development is a big theme for us. So that's where a lot of our thinking is going as well.
Thanks. Other questions?
So you mentioned the TLS connection security to the chargers. Could you say a little bit more about the certificate generation and management? And additionally, if you are considering any other security features?
That's for you.
From a security perspective, we implement all 3 security profiles as per the spec, hopefully. Obviously, we'd strongly recommend everyone against using unsecured transports. From a perspective of Profile 3 with mutual TLS, it's just issue a certificate and pop that in and it just works. So that's the focus of our security stuff. It's just been doing the main profiles so far. Obviously, we're working at the CSMS level. There's different stuff going on in the charge station.
Hi, I have one question. How did you measure the load that you're sending to your MaVe, actually? The number of transactions. For example, you send the OCPP message 1,000 and so on. How did you measure? How did you get the metrics?
So we've instrumented the whole solution with OpenTelemetry. And you can plug in whichever collector you want onto that OpenTelemetry. For our cloud deployment, we're using Honeycomb, which is a great solution. And so we get fairly extensive metrics from that. We also have Prometheus also grabbing metrics from our deployment as well.